throughout every company that we kind of talk to, leadership is demanding different things. You've got chief customer officers who are really looking at how can we preserve revenue. And thank you to the folks here in the chat, Aaron Howe, spotting our first GIF for the day. So congrats to that. So really what we're looking across in the internal view is you got the CFO who's trying to cut budget but not hurt that CX experience. And you've got support VPs who are really trying to tamp down critical issues. Support managers want to be able to see more. So it's interesting to kind of look across the spectrum and see that there's clearly a need for a more proactive support model. And that's really where we think it starts. So where does this proactive support model and this change come from? It comes and it starts from understanding and acting on sentiment signals that are hiding in every support interaction. So this is more than just looking at the metadata or looking at a specific subject line. This is, as you can see from this graphic that we have here, it sort of shows a little bit about what customer sentiment is it's breaking down what's happening in the case. It's labeling those things. So it's saying, this is a critical issue. This is a piece of information that's telling me that a customer is waiting. This is a piece of product feature. And what's really interesting about customer sentiment is that it's not only a predictive indicator of, hey, these are the things that my team need to focus on right now, but it's also something, it's a label for looking back. So when you take all your support data and you run NLP and customer sentiment analysis on it, now you can label all that stuff with these labels that you see up on the top here. And then you can go back to your support data later using analytics, and you can say, well, I want to look at every account that's using a certain product that had a churn risk or had a critical issue. So it's really neat how you've got this sort of predictive, proactive element to it, but you've also got this ability to sort of switch on all your support data from the past and make it a lot more usable than it is now. That's the part that I call the needle in the haystack that I think is really interesting. So I think this further breaks down some of the difference of reactive versus proactive. And we've got another GIF here. It looks like, to my eye, it looks like Lindsay was the first one in on this one, but I'm going to let our producer figure out who won. And but actually, the answer is Home Alone 2. So it goes to here, because that's Lost in New York, where sorry, we're digressing a little bit, but where Kevin goes to New York and he's greeted by the limo and he gets the pizza. So anyway, sorry for the digression, but kind of getting back into our topic, this really kind of analyzes what's going on when you look at reactive support and proactive support. When you're using AI to read every case, and then you're using AI to pull out predictive indicators, you're really moving to that proactive support model. And that's what we've seen happening with our customers, is going from, you look at this list on the left of firefighting and large backlogs, sort of generic AI solutions, and moving into sentiment really being that first building block of observability across all cases, reducing escalation rates because you're able to see the cases that matter the most. You're reducing MTTR. There's some really interesting things, and that kind of leads me into the next part of this chat, which is talking about some of the results that we've seen across using customer sentiment. And those include a company like Coveo cutting their mean time to resolution in half and their escalation requests in half. And then Salesforce cutting their escalation rate in half and giving an hour back to every support manager's day, which translates to that 13%. And you can see here across Databricks and Fivetran as well that they've had incredible results. So it's interesting to look across customers that have great adoption and how they're using these proactive signals to really change everything happening in support. And kind of tying back to our theme, it really all starts with sentiment analysis. So before we kind of get into with Anne some of the the details around how sentiment analysis works and how NLP works, I wanted to dive into this interesting study that we did that kind of drills it even further. So this is really interesting. What we did here is we wanted to look at the benefits of sentiment analysis, predictive signals, and a proactive support model. And what we found across these next few slides I'm going to show you is that these proactive and predictive indicators reduced MTTR across almost all of our customers, across all types of cases. And it was a really interesting conclusion that this stuff really works. And so when you look at this first area, what we did was we looked across all cases of all customers for the year 2022, and we separated them into these different buckets. So we looked at very old cases. So down here in the bottom right corner, these are very old cases that we call the 90th percentile. And then we looked at very young cases as well. And then median cases. So you can see across all of these cases that they've all, when you look at the, and we're not looking at volume here, we're looking at time versus age. So in all of these different types of cases, they all started to resolve faster. Your very old cases started to resolve faster as the year went on, and your younger cases also started to resolve faster, which is a very interesting starting point, I think, with this. And it contrasts very well with the next slide. So now we're looking at all of these types of cases, the young cases, the older cases. You can see here in the colors, you've got young cases in blue and you've got the oldest cases in purple. And so now when we compare them across each other, you can see as the year goes on that looking at this purple line, your older cases go from being 12% of your total amount of cases to down to about 7% of your total amount of cases. While your younger case types, your blue and your orange, those rise. So through customers using proactive signals, sentiment analysis, they're resolving all types of cases faster. And then younger cases are starting to overtake older cases. So it's a really interesting trend. And then to kind of dive deeper into this study, I thought it'd be really interesting to look at, okay, well, what about the volume across this year versus last year? Maybe there's just fewer cases. So we looked at case volume of 2022 versus 2021, and they're virtually the same. So it's great to kind of look at something like this and say, all right, well, we can call these 2 years a static. So if something's happening in 2021 and 2022 where cases are being resolved faster, we at least know that it's pretty much the same number of cases across the 2 years. And then the third part that I think is really interesting is this hypothesis that comes out. Well, what if they just hired more agents, right? What if these companies just went and got a whole new slew of people to handle these cases? And that's why things are being solved faster. So we look at that piece, and that's interesting too, because in 2021, they were hiring more agents. But in 2022, you can see that this line is generally pretty flat, especially when you compare it to what we're seeing in these earlier charts, where older cases are definitively being traded out for cases being solved faster across all ages of cases. So I think that's really interesting. And it kind of gets us into our next topic, and where Anne's really going to kind of shed a light on what's going on with this technology. Can you tell me a little bit about how this technology is built?
As Ryan said before, I'm Anne Barry. I am the customer-facing data scientist here at Support Logic. That means that I not only have, hands-on work with our models, especially a lot of focus on our sentiment models, but I also interface with customers and customer-facing employees to take into account customer feedback so that we can build an even better product for you all. So this is a really exciting time to be in machine learning. The amount of data that we are generating is growing at an unprecedented rate. Right now, the amount of data that we generate in the tech world is predicted to double between 2021 and 2025. And that doubling time is increasing year over year. And so right now, we have the combination of groundbreaking model architectures plus the sheer amount of data. That means that we can train models that detect and make inferences that in ways that are comparable to humans, but we can also do them more quickly because of the amount of computational power of these models versus what humans can take in. And then that means that these models can outperform humans in some cases and overcome sort of biases we have in the way that we take in information in the world around us. So it's a really exciting time to be in this world. I come from a background in teaching, so that also means that I'm especially interested in language. So I love working on our sentiment products. And then do we have, yes, Lindsay, congratulations, you did it. So we got Buddy the Elf there, right in the top corner, enjoying his coffee, obviously. Yeah. Probably before he has the spaghetti with maple syrup on top. I believe that's his favorite meal. So Ryan, could you take me to the next slide, please?
Yeah, so we're 3 gifts down. We got 1 left, right?
Mm-hmm. Yes.
All right. The last one's a little tricky, right? They gotta keep their eyes open. Okay.
Okay, so as I said, these machine learning models have an incredible amount of power to not only mimic what we do as humans, but even go further and detect patterns that we ourselves could not pick up on. But at the beginning, a model is much like a toddler. So even the best models and algorithms need some help to perform similarly to humans in certain tasks. One could compare the training of a language or image classification model to childhood language acquisition. So in this case, the model is the toddler. The toddler comes pre-programmed to take in data, store it, and synthesize it. But they're essentially a blank slate at the beginning, and they don't have any data when they are born. And so they learn language and pretty much everything through exposure to their environment and countless observations. They're kind of figuring out what is associated with what objects are associated with what words, sort of by trial and error and the reinforcement of what humans around them are telling them. So a toddler might have these observations and hear these words associated with them. So they see that top left image, or they're in the room with that actual creature, and someone says cute cat. Then they see this doggy with this little lab, and someone says that cat thinks the dog is too close. Someone sees this dog leashed up to maybe a pole or something outside. Someone says good dog. And then the last one, someone says cute dog. And the toddler's all the while taking this in, trying to figure out what these meanings are. So then the toddler goes ahead and sees some more creatures and feels confident about speaking about them. And they say, for the top left, they go dog, bottom left, cat, top right, dog, and bottom right, cat. And the toddler is 50% correct. So Ryan, do you have any thoughts on this?
Yeah, looking at this first slide, it's funny.
Sorry, we didn't switch slides. Oh, I'm so sorry. I should have given you the hint. The cue.
No, it's fine. We'll jump to that one in a second. But what I like about this one is that in the bottom right corner, like to me, that kind of looks like a cat because of the fur, right? And so when we jump to this next one, yeah, it's interesting because there's some real signals happening on these two on the right. And shout out to Brian getting our last GIF. It looks like Brian jumped in there right before Channing. Great guesses on Homeward Bound. I didn't know the Homeward Bound one, so kudos to both of you for getting that so quickly. So what's so interesting about on this right side is that you have a cat with a leash and you have a dog on a cat playset, right? So there's this idea of a potential for confusion, and I think that's really interesting when it comes to customer sentiment, because that's happening all the time in the way that we speak, right? Like someone will say, I think a classic example is someone will say that's bad and they mean that that's good, right? That's kind of a cliche version, but there's this confusion that can happen in language where something can mean one thing and it means the other, which is where the tuning comes in, right, Anne?
Yeah, exactly. And so in this case, an adult sees that their toddler is getting something correct and making some mistakes. And rather than just, being like, okay, we need a new toddler, we got to start over, this one's defective, they give that feedback. So much like our customers who are active in labeling data, either if they think we should include a sentiment or if they disagree with a sentiment, that feedback is incredibly helpful. And we do use that with our models. And in fact, those examples of false positive, false negatives, those sort of quote unquote tricky ones are really helpful for the model, because the model really does need to see to determine where that sort of fine line is. So yeah, this toddler had observed a cat in a cat tree, and so they might have thought that just the action of being in that artificial tree makes something a cat. They are now learning it has something to do with the actual creature itself beyond just being in the cat tree. The dog also happens to have the same coloring as the tuxedo cat, so that also, if they've seen some tuxedo cats, they might get confused. And as Ryan pointed out in the previous slide, someone called that gray creature a dog, but it still might be confusing for that toddler. They might say, okay, if that's a dog, then I guess things with like those short pointy ears, maybe those are also dogs, but I've also thought that people were saying those were cats. The toddler's not thinking this explicitly, but it's just all of this is to say that it takes a few rounds of trial and error, and also lots of data for humans to create these concepts of words. What's really amazing, though, is once we do develop these concepts of words and their meanings, that again, sometimes we can define certain words. I can tell you what certain words mean, and then some of those words, I'm like, I just know what it means. I know what the word good means. I know what the word the means. I can't tell you necessarily. This child will then be able to synthesize different words and meanings and come up with new concepts that no one had necessarily taught them before. So if this child has learned about wild animals and this child has learned about cats, but no one has talked specifically about wild cats to that animal, they might see an image of a lion in the Serengeti, and based on the combination of cat-like features and wild surroundings, they themselves could come up with the concept of a wild cat without being taught it, which would make me sad, because that means no one's showed them the Lion King when they were growing up. But other than that, that's pretty cool that humans could do that. And so much like toddlers, these AI machine learning models need to be given information before they can harness the power of that hard wiring they have to uncover these patterns. One thing we can do to improve a model is we can always get more data. There are some sort of parameters in the back end that are fairly technical that you can change to get better results. And it always just depends on a lot of things, what's going to work best for your model. Another thing that you can do is you can play around with this threshold. So as I said, usually the default is to say any outcome, any predicted probability 0.5 or greater, we're going to tell the end user that that's a dog. And below that, we're going to say it's not a dog. And in this case, because I'm living in a world where there's only cats and dogs, if it's not a dog, it's a cat. And so if I have a wild set of cat and dog data that the model was not trained on, but then we use that to make, we're predicting on this new data, just like that toddler seeing a set of cats and dogs that never seen before. We're going to get some predicted probabilities out of this. And what I've done is I've ordered them in descending order of predicted probabilities. So if we say that the threshold is 0.5, that dividing line is between that bearded collie looking cat. I had a bearded collie growing up, so to me that looks like a bearded collie, but it's a cat. And that vampire bat looking cat is the dividing line. So everything to the left of that, to the end user, we'd say, these are dogs. And everything to the right, we'd say, these are not dogs. And if you look closely, you will see that some of these predictions are wrong. But you also might notice that some of the incorrect predictions are, you might empathize with them a little, or sympathize with the user architect of the model of why these ones ended up being incorrect. You might actually, maybe this dog has a very good disguise, but there is, or there's a cat there. You won't believe this. There's a cat dressed as a Dalmatian. If you look really closely, yeah, it's really good disguise. So we have a cat dressed as a Dalmatian. We have another cat dressed as, like, I don't know, like a cartoonish looking dog at 0.7. So the model's like, I think this is a dog. I'm pretty confident 0.7 is pretty high. And then we also have a dog that was groomed to look like a tiger. And then we have that ginger dog at the end that to me looks actually pretty cat-like. And so you can kind of see, we don't want our model making mistakes. So we might actually, if we're not satisfied with these results, we could actually take these results and include them in a training set to make a new model and then evaluate on a new test set. We would never evaluate on the existing test set because that's sort of cheating, because the models are, if we for like our final evaluation set, it should be something that the model has never seen in training. But the truth of the matter is, with any classification model, there are going to be some mistakes. So you do need to figure out what sort of you are going for with your model. Let's go to the next slide. So right now we see that we have, 3 true positive and 3 false positive predictions for being a dog. We can go to the next slide. And then we have 2 false negative and 3 true negative. So everything circled is an actual dog for the negative class. We can go to the next slide. And so that means that the precision of this model is that 3 out of 6 positive predictions are correct. So that's 50%. And we can go to the next. And then for recall, recall means that of the 5 dogs that are actually in this set, 3 were positively identified. So we captured. I think of recall as literally like calling in. My best friend growing up, her mom could whistle out the window, and it's sort of like if she was trying to track down 5 kids, recall of 60% would be 3 of her kids actually came home. And then sometimes she would actually, I would sometimes go home to her house. So then I was like a false positive. I should not have been going to her house, but I was like, Mrs. French has good food. And so in this case, we have a recall of 60%. So we can move around that threshold to get different results. Ryan, you can go to the next slide. So what if we are sensitive to false positives? So in the previous example, we had 3 false positives. We had the bearded collie cat, we had the Dalmatian cat, and we had the cartoon dog cat in that mix. We don't want them. We don't want any false positives. For our business model, for our purposes, we would rather have less recall. We would rather give up some of my children coming home, but I do not want Ann Barry in my house one more day. So I do not want any false positives. So I will set the threshold to give me fewer false positives. So if you go to the next slide. So if I had set the threshold to be 0.75 and above for this set, I end up with 100% precision because everything of the positive class was correct. But I did miss some of the kids. Some of the kids never came home, but at least Ann Barry didn't make it into my home. So I think you can go to the next slide. So in this case, precision is 100% and recall is 40% because 40% of my children came home. And so that there's a lot of use cases for you want to make sure that you have high precision and at the expense of recall. There is a trade-off. In a perfect world, they'd all be ordered in terms of their class value, but that rarely ever happens. Yeah. So let's say that you you really want to make sure that all of your children make it home, and you don't care about the stragglers coming in. So you're going to change your threshold accordingly. So Ryan, you can go to the next slide, and then the next one. Yeah. So in this case, Mrs. French has decided that she really wants to make sure that most of her children get home. You notice that she doesn't want all of her children coming home, because she does kind of like not want to like get too many stragglers in there. It's like a little bit of a balance. And also Mrs. French would be like, she would be so pleased if I was talking about her right now.
I love the analogy. Yeah.
Thank you. Yeah, I just came up with it, but it just like the whistling, it was just the calling in, the recall. You're trying to get all of your children home.
Yeah.
So in this case, you can go to the next slide. We have a precision of 44%. And just to make sure everyone's on board, because I am a math person, I love all of the numbers. Ryan, I'm putting you on the spot. Why is precision 44%?
Precision is 44%. I can't tell you exactly why, but I know it's because you got a whole bunch of things you don't want in that recalled bucket, right?
In the positive class, we'll call it the positive predictions. Yeah. So we have 5 false positives and 4 true positives. Yeah. So that means we have 9 children coming home, but only 4 of them are ones we wanted. So that's 4/9, which is 44%. And so then for recall, we did get 4 out of the 5 children to come home. And so that's 80%. And, you know, we could have set the threshold at 0.28. Again, it's like whatever that person's tolerance for false positives and false negatives is. A very classic example of something that would optimize for getting the highest recall possible is diagnostic exams. People, especially first round of, you know, biopsies, it's very common for people to get flagged for having something unusual in their test or whatever, but then actually not have the disease. And that's because these tests are meant to be very sensitive to any indicators that someone might have an illness. And so because the stakes are very high if you miss true positives. So that those kinds of cases, people will want high recall, and knowing that the precision may be lower. Okay, so you can go to the next slide. Yep. So this is all to say, when we are training a model, we are taking into account a lot of different things. So first of all, we're taking into account the fact that this is a machine learning model that doesn't necessarily speak our language as fluently as we do, especially when it comes to sort of like colorful phrasings for things. We also can change around a lot of parameters in the training process, as well as the threshold afterwards to meet our goals, depending on what our sensitivity to certain outcomes is. A really, really important takeaway, though, which I didn't go into detail about, but we are at a phase with natural language processing where we are not actually training these from the start as if they are toddlers that are blank slates. We are not starting with a blank slate. We can use existing models that are pre-trained on millions and millions of pieces of text, so that these models come in knowing a lot about the English language, about not only just like what individual words kind of mean, but also how different words are associated with each other. And there's all these different models out there that are based on different kind of building blocks, but come at the same idea that they're pre-trained on millions of sentences. So then where we come in, it's sort of like we've been given a very, very intelligent college student who has learned to read and write and write essays and general topics that you would find in an English class. And then they find themselves in like a law class and need to learn how to write specifically for the law. Their prior knowledge is incredibly important, and we are grateful that we are not teaching them how to write a thesis, right? They're coming in with that. So we bring in the domain knowledge, the data, your feedback to build these sentiment models and really expand upon the knowledge that is already out there and available to us, in 2023. It's incredible what's out there for us to use. And I cannot emphasize enough how important our customers' feedback is to us, because again, humans are incredible with their way of communicating things. And so the more examples we get, the better. And so we really appreciate the people who have been giving us that information. And we're working tirelessly on making that feedback cycle even quicker. And we're using human review and AI to evaluate that feedback that comes to us, because it still actually does need to be reviewed, because sometimes the feedback that we get is actually like incomplete sentences, or sometimes even incomplete words have been highlighted. And then also we sometimes will recategorize some of our feedback, because frustration, what someone deems as frustration, we might actually call impatience and all that stuff. But as a person who's working on this actively, I cannot tell you how amazing it is to have all of this customer feedback. And I'm really excited to keep building these models for you all.
And thank you for such an incredible breakdown of how NLP is built and how it kind of relates to sentiment analysis. And I think it gives such an important context behind every one of these labels. Like when you see urgency or when you see churn risk, you can now relate it to, this is a model that's trying to like identify a dog or a cat, right? It's sort of reading through a lot of data and trying to pick out those moments. And I think that's really cool. At this point, we're going to dive into the product a little bit and show what this looks like across Support Logic SX. So sentiment analysis is a really funny thing to demo, because sentiment analysis, sentiment signals, sentiment scores are one of the underlying elements in the entire product. It's one of the like building blocks behind so much of what's going on in here. Right now on my screen, and let me try to kind of zoom in a little bit so you can see it hopefully a little bit better. I don't know if that actually worked, but you can see here that there's all these cards on the bottom of my screen, and you can see that there's like a little sentence that looks like it's being pulled out of every one of these support cases. These are the specific pieces of sentiment that are being pulled out of these cases. So if we look across this row here, you can see, well, I want to look at cases in my support queue that are pulling out signals of confusion from my customers. And so when I click confusion here, because I have this group by signal type, I can see immediately what cases have confusion happening, what cases have customer frustration happening. And then I can open up the case and I can click at the top here and get right to where that's happening. So all through the product, you're getting sentiment labeled, but then what you're also getting is this machine learning model, that takes all these signals, how often a case has responses, when a case was opened, how a case compares to a customer's previous cases, what's happening in the case, like for example, with these signals, and wraps it all up into a sentiment score. So it's like kind of like the temperature reading for a case. How is a customer feeling? How is this case going for this particular case? And it's such a great way to prioritize all cases. So this kind of ties back into some of the studies we were talking about earlier, where when you look at backlog and you look at being able to organize your backlog across all these different ways, whether I want to organize backlog by escalated cases or by older cases, you can see right here, I can filter by attention score or by sentiment score. And right there, there's that number kind of telling you how important that case is compared to the next case. So you're seeing sentiment across the product in two different ways. You're seeing it as this kind of heat signal, and then you're seeing the specifics of it too, which I think is really cool. So If you get into something like the agent view, and right now we're looking at 3 different agents, and we're looking at their backlog across case status and across case age. So you can see I've got older cases, and they're all in kind of an escalated condition for this agent Leah. And you can see right away, well, I've got this case is orange, so something is sort of getting a little worse in this case. But this case is green, and it's doing a little bit better. It's a 79. The temperature is kind of okay for that case. And then you can see for Daryl. So right away, what's great about these proactive signals is that they're able to focus your energy. What do I need to look at right away? You go to a screen like this and you want to look at the red cases right away. Those are the areas that are going to need your attention first. And then kind of getting back into the console, you can look at cases that need attention. And then right away you can see, oh, I've got these are cases that are rated that they need my attention the most. And because we're looking at cases that need attention, now you're getting a spectrum of signals. You're seeing critical issues and follow-up requests and production issues. These are all tags that happen automatically as your cases come in. So what's neat about this is that it's almost like if you hired someone to read every single case that's coming into your queue and take notes on what's happening in those cases, and then organize those notes in a way that you can go back to them later. Because when you look into like the analytics side of the sentiment analysis and some of this stuff, is that you're able to filter these things down. Let's bring in some of these other signals, and you can go back at your signals that you've already had put on your cases through the AI, and you can look at exactly what was happening at any period of time. So we can go back to June, and we can kind of see what was happening then, and we can see using filters across platforms and products, and you can see here across a multitude of regions and accounts, you can really kind of dive into and filter down into what's happening in your history and go back. And that's really where you're influencing product roadmap, where you're spreading those insights across your whole organization, which I think is a great part of this slide. When we look at this, there's real company-wide benefits to using sentiment analysis across the entire organization. Your agents and your support managers, they're getting more efficient. They're doing their work in a more productive way. But then when you look at the right side of this slide, now you're giving IT a way to really figure out how their resources are going to be spent. You're letting your leadership kind of figure out where are the points that we need to focus, where are the at-risk customers. And a really exciting part of all of this is that you're letting your product and your engineering team look back and say, let me go back to the product here. Where's the product feedback? Like, let's look at this blue one right here. Back in June, we had a feature request for this one particular thing. So there's so much interesting possibilities in here, and it all starts with sentiment analysis. All of the cases are being read, they're being tagged, and then you're able to use it to be proactive, but then you're also able to use it to kind of go back. And that's kind of the point with this slide, is that you're getting historical markers and forward indicators as well. You're influencing roadmap. And then I think as a big picture, what you're doing is you're taking customer support and you're really turning it into this driver of customer relationships and giving it the ability to really help that customer life cycle. So that's a really exciting thing. Thank you for joining us, and thank you for the very detailed and incredible breakdown of what's happening with this technology.